Uh, well, thank you everybody for coming. I'm going to be talking about some of my dissertation work. This is one small piece of a larger sort of investigation into a really interesting little fish called a mosquitofish. How many people here know what a mosquitofish is? Raise your hand. Oh, that's pretty good. Usually nobody knows what I'm talking about. It's probably one of the most abundant fishes in the Bahamas, especially within the sort of nearshore environment, except they're really, really tiny, so most people actually overlook them or there's other sort of names for them. The mosquitofish is like I said, it's a small fish, so it's about an inch long or so, a couple of centimeters. They're sexually dimorphic. The female is the one up top here, and the male is down below. The male, you can tell really easily, they have this modified anal fin, which is called a gonopodium, and they actually use to inseminate females. But right now, what I'm going to be talking about for this talk is this feature right here called a dorsal fin. Males exhibit a really brightly colored dorsal fin that they use in courtship displays to females. Let's do it that way. Now, there's a really fascinating thing. Once I started working on mosquitofish, I noticed that from place to place, I was seeing a lot of variation in what these things looked like. So all of these fish represent sort of some of the variation that you would see on simply the island of Abaco. As you move from Blue Hole to Tidal Creek to Mangrove Swamp, oftentimes you'll see the fish change a lot in the way they look. Now, these are all males, but you can see there's a lot of variation in some basic features like the number of spots, the sizes of spots, the color of the body, and the color of that dorsal fin. The color of the dorsal fin tends to vary from sort of a light yellow to a deep orange or almost red in color, and that's really what the kind of variation I'm going to be talking about today. And the thing I'm going to be talking about is trying to understand what's the source of this variation. Where does this come from? Why did these vary? All right? To do that, we're going to actually take a step back. We're going to talk about some of the sort of evolutionary theory behind why these fins might vary. And if you're going to talk about sort of sexual features and evolution, a good sort of case study is the peacock. So from mosquitofish to peacock. You all with me? All right. So the peacock's a really good example because people have been really curious about what's the origin of this pretty extreme trait is. I mean, peacock has this long train. It's really sort of improbable, and it's really magnificent. And people have thought about it for a long time. And actually, Darwin was sort of deeply troubled by the peacock, as this quote sort of expresses, that the sight of it actually made him sick. This is in a letter to his friend, so pretty relaxed conversation. But the thing that bothered him about the peacock's tail was that it really shouldn't exist, right? So the reason it shouldn't exist is it's extremely costly, all right? So it's not just really large and expensive to produce this material, but actually it makes it really hard to fly, all right? So peacocks aren't great flyers, and that tail doesn't help. The other reason is that it makes it sort of more obvious to predators, presumably, that this tail may actually be costly if they sort of fall into a polar bear enclosure or a panda bear enclosure. I couldn't find too many sort of videos or photographs of peacocks actually getting eaten, but anything but some pretty artificial scenarios. But presumably these tails predispose these peacocks to predation. So we're talking about a really costly feature. And so Darwin couldn't understand why such a feature would evolve, right? So you have this animal that's bearing this extreme cost, and it just didn't make sense in the framework of natural selection. A couple of years later, he resolved this sort of apparent paradox by realizing if there was a benefit to bearing this sort of costly feature, you could perhaps get its evolution. And the resolution was that females, if they prefer these sort of extreme traits, may actually be able to counteract that natural selection force. And these turkeys are lined up, and the female's presumably evaluating one, and she'll maybe make a decision based on who's got the larger or more impressive tail. Now, I wasn't going to include this, but on the taxi ride into town, I pretty much saw this happening on the beach, so I figured, this is a pretty familiar scenario, but it's a real scenario. And so when this type of behavior starts sort of being exhibited in populations, you can get what something called sort of a balance of selection model. This is a really basic sort of diagram or very sort of heuristic model of how the evolution of sexual signals evolves, but you have this ecological cost like predation, energetic expenditure, and so on. And then you have this sort of female preference, and these two countervailing vectors may actually produce a male signal. And there's this quote down here from John Endler, a pioneer in this work, who talked about this sort of balance of selection. So it's natural selection balanced by the benefits of being, the sexual benefits of being conspicuous. And the way it basically works is, if you change the balance, right, in this case we've reduced that natural selection strength, you may actually get an increase in the sort of elaborate nature of the signal. If we increase the ecological cost, we maybe get a reduction in the extremity of that feature. So this is sort of the background that we're going to use to investigate all this interpopulation variation in mosquito fish. And so what we did is actually went to Abaco and I started sampling pretty widely different populations and measuring their color. But we had some ideas about what might be driving this. The main sort of, our primary culprit or a real initial focus was predators. We thought that these populations that varied a lot in their sort of predation pressure might be changing color because of changes in that sort of natural selection strength. And if these predators were actually involved in this, we might expect to see something like this, where in places where there are no predators, you get this sort of increased redness, and in places where there are predators, they're more dull. So pretty straightforward prediction. Went out to, I think we had about 16 or 17 different sites in this study, a bunch with predators, without predators, sampled a bunch of mosquito fish from those populations, also did some pretty in-depth predator surveys. And what we found was that predators really had no explanatory effect, right? There was no sort of variation between predator and no predator populations in the color of these fins. So that kind of fell flat. Although it was interesting, it wasn't what we expected. So it looks like in this case, predators aren't really that important in driving this sort of balance of selection model. But I wasn't quite convinced, and I wanted to do it again. But I also wanted to include this other thing that seemed to be sort of sticking out. Just actually doing those predator surveys, being underwater, you see a lot of the sort of behavior of the fish. You just start to realize a lot of the different things that could be going on in these ecosystems. One of the primary ones is the color of the environment varies drastically from place to place. So you can have these bright blue waters that we're sort of used to in the Bahamas, but you can also get these extremely deep red environments. These environments are deep red because they're full of dissolved organic carbon, tannins, and things that leach out of decomposed plant material. And it builds up, and it's basically like tea, right? So it sort of seeps into the water and gives it a strong color. You can have sort of less intense coloration as well, but when you move around these different ecosystems, you see there's a ton of variation, and it's pretty notable. And so we thought this might actually be involved with the sexual signal variation in our fish. So what we did is, so even though there's a lot of variation, that variation can more or less be summarized as a gradient, right? You get these sort of clear blue waters, and then you get sort of intermediate levels of color, and then you get the strongly colored extreme. And the reason I thought it might be important is because I noticed that all of my clear blue water sites tended to produce males that were really yellow or dull in coloration. There weren't a lot of clear sites that had really bright red individuals. So I imagine maybe there's something going on here. And we just made a really simple prediction. There wasn't a whole lot of thought behind this one, but we considered that perhaps this gradient could be explaining this color gradient in the fish. And again, if this were true, we might expect to see something like this, where as the water goes from blue to red, fish go from blue to red. So this time I repeated it. I did a bunch more sites, so we had about 22 or 23 sites in this study. But this time I did predators, but I also measured a lot of different things. One of the primary ones was the color of the water. Now, it's not necessarily straightforward to do. You have to sort of transmit light through a sort of a section of water and look at what's removed, right? So we did this for a bunch of different sites, collect water samples, shoot light through it from this end to this end, and look what sort of wavelengths are lost. And we did also sort of some in situ studies where you actually drop a probe in the water and sort of look and see what the color environment is. So we had pretty good measurements of actually what the spectral environment was for all of these places as well. Again, predators, all right? So we had another study basically tell me that predators have no effect. I won't go into the details of the results because they're detailed, but basically, again, we just showed no signal of predation driving the interpopulation variation in color. So I'm starting to get convinced. And remember our prediction about the effect of watercolor. So these are the data these are means from the population. And what we can see is that across the first part of that gradient, from yellow to about greenish, blue to about greenish yellow, we actually see that predicted relationship, right? We predicted that there would be an increase. And that's more or less what we see. So that was pretty exciting. It was starting to see a bit of pattern show up in the data, except when you go out to the extremes, that relationship actually reverses. So now you've got fish going from yellow and blue environments like we had seen previously. They get more colorful, so more orangey red in the intermediate levels of that gradient. And then as you go off here, they become less colorful again. All right, so this is a pretty unexpected result. I've actually never seen this sort of thing in the literature, which means it's hard to explain. But basically, I'm not quite sure what's going on here. But there's definitely a strong predictive relationship of watercolor on the coloration of our local fish populations. I have some ideas about what might be happening here, but it's definitely clear that watercolor affects population color. So, fin coloration is driven by strong gradients in watercolor, and the effect of predators actually seems pretty minimal. So, what does this example tell us about the world more generally? I mean, this study, I use mosquitofish as my sort of model species, but what can we learn about basically the evolution of sexual selection systems through mosquitofish? Well, this is sort of unsatisfying because I just taught you this model. But it basically suggests that this basic model that's really prevalent and is used basically everywhere when talking about the evolution of sexual selection, sexually selected signals, probably isn't right because this sort of natural selection side doesn't seem to be stronger than other aspects of selection here. We're not even really detecting any effect of this sort of natural selection on the local variation of the sexual signal. So it kind of suggests that perhaps this isn't even operative. And maybe we should start thinking about other sort of models of sexual selection to really understand what's driving the evolution of species and their extreme traits, like as in the peacock. And that's all I have for you. A lot of different funders, and thank you. And if you want more information, you can go check out things like Abaco Scientist. I even have a website that's terrible, and some other things.